Hello everyone! Today's video focuses on exploring a new AI framework. It's another method for creating TikTok-style dance videos. I understand that many of you enjoy using Stable Diffusion and Animate Diff to create dancing characters. We're going to play around with another new one called ControlNeXt. ControlNeXt is an AI framework developed by researchers from the Chinese University of Hong Kong and SmartMore. Before ControlNeXt, we talked about another animate dance framework called Mimic Motion, which has a very similar mechanism that uses stable video diffusions with DW pose. However, what I've noticed from their GitHub page is that they're also utilizing other training models, including SDXL and SD 1.5 for image generation, and they've just separated different pipelines into different folders. Of course, the animations use SVD, specifically SVD version 2, which utilizes the SVD AI modules 1.1 to produce these videos. Their mechanism in this pipeline is based on replicating Animate anyone to create such videos. Let's check it out. They're using DW pose for the poses, the motion movement like what we see in this demo page, the reference character using a single image, and capturing each pose motion in each frame using SVD for the animation process. They also have coherent styles of the character. Any type of object will not be easily deformed or morphed. Additionally, the outfit and backgrounds maintain a consistent style due to the use of SVD, which is significantly more stable than Animate Diff. As we've experienced a lot with Animate Diff videos to videos and other image to video workflows before, there's a lot of time that we have to fight with the consistency of the character's animation. Stable video diffusions, using a modified control net specifically designed for the video models, can effectively address these issues. I recently came across a research paper on this topic. Upon review, the research paper primarily addresses various challenges faced by numerous content creators when producing images and videos. First of all, the efficiency. ControlNeXt is designed to be lightweight, unlike other models that basically double your GPU usage when you generate AI videos. This is an attempt to maintain a more linear processing flow throughout the entire framework pipeline. I believe this is beneficial for end users like us who prefer to utilize local AI models, as it allows us to save on both computing power and electricity bills. Secondly, I believe that using this framework offers greater flexibility. In theory, they're handling both images and videos very nicely by keeping the pipeline, if that makes sense. Even though they're doing SD 1.5 and/or SDXL, they're applying the right control net models that match with the diffusion models correctly. So it's also able to handle very good imagery, from what I see on this demo page. In this video, we will primarily discuss the ControlNext SVD version 2, which shares similarities with Mimic Motion. However, to assess the quality, I need to conduct a side-by-side comparison between the ControlNext SVD v2 and Mimic Motion, both of which utilize the same mechanism. They try to replicate the implementations of Animate Anyone, but I guess Mimic Motion has some modifications in the VAE and also the UNet sections, and the ControlNext SVD is just purely using the stable video diffusion weights that modify the DW pose to control the character pose with each image frame. Therefore, we need to compare the differences and determine whether the process will be as smooth as what is shown on this demo page. Because, they always show the best cherry-picked ones on all these project demo pages, right? And so we've got to try that. Additionally, improvement training is quite simple to implement. You can see numerous folders here, each displaying a different pipeline. They also have a folder dedicated to training. They have their own coding to facilitate further fine-tuning and enhancement. If you don't like what they have, the existing base models, you can train your own models as well. So in ComfyUI, there are custom nodes for ControlNext SVD, so you can check that out. I'll include all of these links in the description below. As you can observe, these custom nodes already feature DW pose examples and a pipeline. As they have seen in this project, the SVD v2, they also have those pipeline folders, DW pose examples, models, everything is the same. But just in the ComfyUI custom nodes, they implement the custom nodes that are able to integrate and implement inside the ComfyUI system. So, installing this is pretty simple. You just go to ComfyUI. In ComfyUI, you go to Manager. Let's clear off the workflow layout, and here's the ComfyUI Manager. Go to Custom Nodes again, and you have seen this one. Search the custom node list where you see the ControlNeXt SVD version 2. So just install this, restart your ComfyUI, and you are ready to go. I've already installed it, so there's no install button here. Next, we are going to download this SVD v2 UNet FP16 converted safety model. This will be used to animate a character using DW pose, and this is the SVD used in that pipeline. So download this, or you can rely on their workflow custom nodes to download automatically in your folders from Hugging Face. But I suggest you guys manually download that and put it into the folder. That's going to be a better way to keep track of the download progress. So, where do you download these SVD modified save tensor files? You're going to save them in the models UNet folder. As you can see, I have already saved the modified SVD files and the tensors files, which you will find in these model files. They have also automatically downloaded DW pose from Hugging Face, and I'll just let it auto-download this from Hugging Face in the ComfyUI behind the script. Once you complete the manual download of these SVD safe tensor models from my implementation method, you're prepared to begin experimenting. They have the example workflows in the subfolder, and you can use those as well. I'm going to use the SVD Comfy01 JSON files that are going to be running in ComfyUI. So load those JSON files in ComfyUI. You'll have a pretty similar interface like that, but I'm using groups to label this area that belongs to these features, so it's going to be easier to manage and expand this workflow in the future for me. And right here, you have width and height, of course, very self-explanatory input values that you have to do for your videos. And I have also seen the stable video diffusion models as well. Right here, you have to download the stable video diffusions 1.1 in your checkpoint models folder. So in your models checkpoints folder, just paste that SVD folder, and in it we have the SVD XT 1.1. That's just the base model from SVD. You guys can download directly from Hugging Face from Stable Diffusion's Stability AI's Hugging Face page. So once you have that available, then we're going back to the ComfyUI. So refresh the button and we'll see our SVD models here. Now we're using this one, the image only checkpoint loader image to video models. This is by default in the ComfyUI itself. So image only. As you can see, when I type image only in the search box, this custom node already appears. So we're going to connect the clip visions and VAE using the SVD-based model. But for the model data, we're going to use the ControlNeXt converted save tensors file. So in total, we have two files, which is this one we save in our UNet folder as well. Right now, I'm loading that from the UNet folder, and they have a models data connected to the ControlNeXt SVD apply. This is like how you normally use a ControlNeXt custom node like apply ControlNeXt, but using ControlNeXt, they have their own custom nodes to connect, which also injects the data into the models as well in the pipeline, so influenced by the pose images from here. So the ControlNeXt get pose, which is very similar to DW pose preprocessors, but this one is going to be matching the source image for our character and the reference video image frames for our dancing motions, and putting that together in the get pose pipeline in these custom nodes. So basically we have to resize the image with both the reference image and the source at the dancing pose source videos together with the same image size. As you can see here, we have the resize image for both image sources, and then we're posing those data with the SVD conditioning to a K-sampler, and also right here. This is something funny that they're using the Animate diff to use evolve sampling. This is the sampling of custom nodes from Animate diff evolved, and they're using the context options using the standard static one. So that's something pretty fun and very innovative way to modify these three frameworks together in one workflow. Traditionally, we're using the motions model from Animate diff. If we're using this, use evolve sampling custom nodes. Right there, you see a lot of applying Animate diff models when you're connecting the motions model, but right here we don't need to use the Animate diff motions model. We're connecting directly the model data from stable video diffusions and the ControlNeXt modified UNet model to play around with that. So once again, this ControlNeXt V2 UNet FP16, you're going to put in your model's UNet folder, and this SVD XT 1.1 is the normal SVD weights. You put that in your checkpoint folder. After that, we pass all this data to the K sampler, and it's got a split latent that is using the latent B. I'm not sure why it's going to use split index 2, but that's what it was the first time I ran this workflow. So let's try if there's a difference for one for A and B in here. And here I have created another image, frameless, passing the first pass of this ControlNeXt video's result. I'm going to do another, further development in this workflow that needs to receive this data for further features. And in this group, this is going to be the final output of our video result. And let's check out what we have in here. So right here, I set frame 50. Just try it in a short view and let's see how it goes. Okay, so after a minute, we have generated the result. And as you can see, we have the ControlNet pose, or DW pose, I should say. And here we have all the processing, and this is the result. And it looks like there's some bad moment in that hand across that face. Sometimes it happens in mimic motion as well. Maybe this will have to be fixed in the further workflow development of using ControlNeXt. If we have to solve these problems, maybe we can bring it to Animate diff or run another sampler using ControlNeXt to see if we can enhance the image quality. But from this experience in this experiment, I'm going to just test this result by doing one sampling by default of this workflow and a side-by-side comparison with mimic motion. Right here, I have my previous workflow running mimic motion. I disabled all other features and just ran mimic motion, loading the reference image and reference videos. That's the same video as we have, and let's see how that goes again. We're going to set the frame cap to 50, and we skip the first 50 frames because this is the range where we can capture the same actions. Here we're going to test how that reacts in mimic motion for the cross hand in front of the face as well. So here we have talked about mimic motion before. I won't explain too much of that in these videos. You guys can check out the mimic motion tutorial, and we're going to run this and see. So it works successfully passing those poses into mimic motion. We got the DW pose as well. The same poses as you can see, and mimic motion takes a little bit longer to render. I have set some higher steps in rendering, and the context overlap, I set it over 8. By default, it's using 6. So it's going to be taking a little longer, but it won't be too much longer. So for mimic motion, after it was generated, we got the result. As you can see right here, there's still a little deformation on the face when hands cross over those actions. But overall, I like the way that mimic motion is going. The overall character and the backgrounds, all the objects are more stable, and there's some camera movement going on that is moving along with the character movement, looking more dynamic. But yeah, for SVD, for ControlNeXt SVD, there's still some movement going along with the background as well. It doesn't look too static. I don't really like the static styles of like an image stuck on the background, those kinds of videos, but it is not of higher quality compared with mimic motion. And yeah, that is basically how many custom nodes I use in mimic motion. I have not fine-tuned this workflow as well, and other features for enhancement and removing background, I have turned those off, upscaler as well. So it is just running by this group for processing the videos. And it did a lot better, I would say, compared with just purely running with stable video diffusions. Because when you're just using the SVD as the clip visions and the VA is not modified, you're just using the original SVD weights. There's a lot of videos or the imagery motions that are not running that smoothly originally in SVD. So what it does in mimic motion, as we have talked about before, is totally modify these SVD models from their whole AI models, weights, UNet, VAE, etc. So the way that in making them, the motions are going to be smoother than what we have seen. That purely using the SVD as the weights for VAE and also the clip. Well, you can use the SVD conditioning and try to boost up the FPS in here, but the max in the original SVD conditioning is not going too high, Even if you set it to like FPS 30, you won't be able to get a good performance from this, and we can try that by setting the FPS to 30 in the SVD conditioning. You can see the result that it won't be able to receive too much better videos in here. So yeah, before these demos, I had not tried this AI framework at all. Just going to demo this together with you guys. And I have assumed that already because when I see the workflow that's using the SVD image and the video conditioning, it doesn't actually do a lot of improvement because it is using the original Clip Vision's VAE and also the original FPS that's running in SVD. We have demonstrated and tested that a lot before. SVD just cannot achieve that goal. So we can see this result, and let's review it next. So here's another demo result that I'm using. The FPS 30 in the SVD conditioning, and also the same numbers, the frame rate in video combined using 30. But as you can see, it is still a very slow motion. The speed of the movement of the character, everything still remains at FPS 8 or 7 because that is the maximum it can go for an original checkpoint model of SVD. So that is the con of this ControlNeXt framework, I would say. Although they have solved a lot of problems, the morphing or the character consistency of the styles, outfits, background, etc., the speed of the motions cannot be reproduced like the same as what we have in these original source videos, and that won't allow us to create such, TikTok short dance videos that I know a lot of you guys are interested in, but you just cannot produce such videos like that. Even their demo videos are only doing a very short motion period and very simple hand dance and, shaking their booties, etc., but not very complex dance moves or human movements that it can produce. For the sharpness of the outfit and the clothing, I think they have made a few modifications after the first case sampling pass was generated. Maybe they have this kind of result, and then they bring in an IP adapter or whatever they can use to make the outfit sharpen like the reference image. So that is something I assume they did for their demo, but it's a good try. I cannot say that this ControlNeXt or any other anime edit, anyone look-alike framework will revolutionize the AI video generation models, but it is good to see some newer AI frameworks combining different components together, like SVD combining to DW pose, or in SDXL they have done something with the ControlNet as well to reproduce something that is better image quality. That is a good try for research purposes. I think it's okay. But if you want to put that in the production stage, they need a lot of work to even modify the stages that are using the VAE and the clip visions, not going to use the original SVD model, which is maybe it has to do something like the Tencent mimic motion that Tencent did completely modify this SVD model, the UNet, VAE, etc., putting in a single pipeline like that, and you can overcome the FPS problems. Because in mimic motion, I set it to a frame rate that is following the same from the source videos. So in here, as you can see, I have a source video with the same frame rate as 30, and then we are able to produce in mimic motion. So that is what I have come up with so far. Testing the ControlNeXt and comparing that with mimic motion that we have talked about before. And in mimic motion or ControlNeXt, you can also generate the result. For example, here you can do animated videos to videos, but those videos are going to use this output result. So I did another group in here that is using that, so pass that first ControlNeXt result for the first pass and bring it to this group using Animate diff, just purely using the Animate diff version 3 motions model and using LCM for the checkpoint models to run it a little faster, reducing the time, and setting the scheduler and sampling step lower so that we can have better processing times, then that will be something like this. But there's still a lot of influence from the morphing hands on top of the face from the source videos that we cannot overcome because it is what it is generated in the first place. Maybe we have to, totally modify that 1 or 2 seconds of that hands morphing, and that will be doing a lot of work. So after installation and testing of ControlNeXt SVD v2, is it worth to keep this in my ComfyUI? Well, I will not keep it, let's be honest, and I prefer more on Tencent's mimic motion. Just by look at the outfit, Mimic Motion is even creating more detail. As you can see, this sweater and that pants pattern are able to reproduce in this video's result from Mimic Motion. But on the other hand, we see the ControlNeXt we are using the same image, but it is very low FPS for motion. Outfit detail we cannot see very clearly for the sweater. That is the cons for ControlNeXt. So that is it for these videos. I would like to do more a side-by-side comparison and an AI framework review when new things coming out to the market, rather than just tutorial, how to install, how to create. Kind of boring, as I saw some other channels do. And I want to do a little more about this kind of video by doing a review of different new release frameworks as well, which will be more beneficial for people to understand which are better to use or what is suitable for you to use in different situations. So I will see you guys in the next videos. Have a nice day. See ya.